time on those because when they're done right, they work. To cover a broad spectrum of change, you need to have an ordinance in place. I can point to Tucson, which had, where I'm from, an ordinance was enacted in the mid-1970s, and essentially the ordinance says you will shine light down, not up, which is pretty fundamental. And it's really very telling. When you fly into Tucson at night, you see pools of illumination, not points of illumination. You see that which is lighted, not the source itself. And there's a municipality of over 1 million people. I live 6 miles from the city center, and I can see the Milky Way from my driveway every night. So 1 million people, and I can see the Milky Way. How does that happen? Well, we shine the light down. It's not much more complicated than that. We help other communities enact ordinances as they can. We're trying to come up with a model light ordinance, which can be adopted by many communities. There's always contention involved in what should be included and not included in an ordinance, and those are still being hammered out. Luminance design changes. We're always trying to promote the change from poor, inefficient design to good design, meaning the full cutoff nature of control. FSA stands for our Fixture Seal of Approval program. When I took over the program 4 years ago, there were 12 manufacturers that were participating by having good design luminaires. We now have over 100. So what's happening is that businesses are seeing that once ordinances are enacted, or the community is actually starting to pay attention, and they say, well, if we want to sell products in these areas, we better have products designed for those applications. And as we're seeing more and more of it. Quite telling was at Light Build, which is the largest lighting show, happens every other year in Frankfurt. 4 years ago, it was rare to see a full cutoff product. 2 years ago, we saw, maybe 20% of the manufacturers had them. This last April, I'd say 90% of the manufacturers had product lines that included full cutoff. And we're able to include several manufacturers from Italy to be part of our program, as well as another one from Austria. So it's becoming a global awareness, even as well as manufacturers. There are good products out there, and we want to help promote them, which is the whole point of our sealed approval product. Human impact circadian disruption, we're involved with that. Again, intense ongoing research. There's a lot of ideological leaps that are made which can't be founded yet. We'll hear saying, blue light causes cancer. Well, that's something that hasn't been determined. There's something that's rich in study right now. We need to be on top of it to make sure that we're promoting the proper research and essentially saying where more research needs to be done. Revisit old recommended practices. This is a very important thing. When we talk about recommended practices, the luminance levels that were originally specified were not done in a scientific way. Everybody thinks, okay, if something was recommended at, say, 2-foot candles of intensity, that's because we figure 1.9 was deemed insufficient, when in fact it was consensus-based. You had essentially 10 guys sitting around a table, went outside, looked around and said, does this look good? Yes, 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 yes. Okay, 2-foot candles. Let's go have lunch. And that became the law for 30 years. Had nothing to do with the scientific basis of saying, well, let's actually measure what's actually necessary. So we need to start changing some of those recommended practices. And we do that by joining committees. I'm part of the research committee for the ISNA, and I'm also part of the CIE, which is the Committee International d'Éclairage. I'm one of the committee chairmen on the effect of artificial light in the natural environment. So it takes time and effort to insert yourself into these well-respected organizations and say, wait a minute, let's look back and see how we originally came up with these numbers and see if we can start changing them to something more rational and scientific-based. Environmental species impact, my particular committee, the effect of life on artificial life on a natural environment, is ever-changing. There's always new data that's being shown. There's always new disruptions that are being discovered. So it's an ongoing process of finding out what the problems are, collating them, putting them in a large database, and moving on. New alliances, always trying to find partnerships. Make friends, not enemies, is the goal. So our alliances, a very powerful one that we just received was in the United States, the National Park Service. We've been asked by them to come up with a lighting design specifications for their national parks. This has been an omission for, made for dark areas. What should be the lighting practices for those? You know, all the ISNA and CAE have come about for, we need to light up bright city areas or parking lots, things of that nature. And the natural areas have been avoided. Well, we're partnering with the National Park Service, and we're going to develop the standards and practices for those sorts of areas. We'd like to involve UNESCO. I figure every UNESCO site that has any sort of illumination, whether it be interpretive centers or museums and such, should all have dark sky features. We'd like to work with them on that. New sources and technologies is what I'm going to focus on today. That's been a huge thing within the past 3 years. When I started, LEDs were a pipe dream. They were a novelty on a flashlight or a thing on the end of your communication device. LEDs were nothing. Along came the improved efficacies of high brightness blue LEDs, which is really what a white LED is. It's a blue LED with a yellow phosphor coating, shining intense light, and the light emitted is essentially white. So, new sources and technologies. There's also means of control, adaptation, curfews. These are all things that are part of the scheme of changing the way things have been done for decades. And that's probably the hardest thing that we have to do as an organization and as a community, is to overcome inertia. We have 6 or 7 decades of the way of lighting, and trying to get past that as being, that is what is done, to something else. I know it's very difficult. People from the East Coast or the northern climates in America will frequently move to Tucson because it's a warmer climate. And they're kind of astonished by how dark it is. Well, it's not how dark it is. That street light is still on, except it's not glaring. It has a flat bottom, so it doesn't have a bowl that's causing glare. You know, they say, well, you know, the road is illuminated. Isn't that what you need? Oh, but I can't tell the lights on. It must not be safe. So it's just overcoming a perception that people have had for decades. And usually by demonstration and experience, when they were able to see an area that has good lighting, they go, oh yeah, that makes sense. I should be spending my money to light at the bottom of airplanes. Old versus new. This is kind of the lure that's being handed out right now. What would you rather have? This newfangled lighting or the old stuff? New being beautiful, pure white, or that old orange yellow stuff? People look at that, especially when there's a side-by-side comparison, they immediately, oh, I want the white. New technology offers new solutions. It's kind of interesting, though, as far as human perception goes. The orange light is from the traditional high-pressure sodium. The white is from an LED. Yet the intensity is radically different. You're looking over here at about 25 lux, and the white light is about 10 lux. So it's radically lower in intensity, but the human eye sees it as brighter. Okay, now that's a problem, because specifications are written without taking light source and light spectral power distribution into account. So if everything were lighted to the 2.5 or 25 lux level and became 25 lux of white light, the world would be a supernova. It would be terrible. It would be the worst thing that ever happened to astronomy, to have a lumen for lumen equivalence by changing this with the same spectrum. And there's a measurement. Looked exactly at that. That's in foot candles, 2.5 and 1. But that's exactly what I measured at that spot, even though the eye sees it as being not the same. Okay, LEDs and white light. The white light is sort of this glittering lure that's out there being proposed because of new technology. So there's promise and peril. There's good things that are about LEDs that were touched on by Fabio. There's also peril. There's a lot of danger associated with them if they are introduced unrestricted. So we need to make sure that what goes on with LEDs, and they're coming, it's coming like a freight train. We're not going to stop it. It's a technology and improved efficacy for costs, for energy, that they're going to be out there. So we want to make sure that it's done in a manner that's appropriate for everybody concerned. And that includes astronomy, that includes the environment, that includes species disruption, it includes human circadian disruption as well. The promise is the ability to control. The promise is the ability to correct the spectral power distribution that we did not have with older technology. The idea of curfews or lowering light at nighttime or raising it as an occupancy sensing thing is a new technology that simply wasn't available 4 years ago. And it's a radical new shift in how people would begin to accept and function in light at night. So we have to overcome the inertia of the way things were done and use those things to our advantage. They're coming, so there's a good thing about LEDs, but there's also the problems. Raising awareness, we came out with the blue light paper. Initially it was talked about in October. We came out with it in May, and this might as well have been almost committing suicide for the International Dark Sky Association. We, by saying this, we essentially said, wait a minute, we have to hold off on these LEDs. We need to have the research done. And a lot of corporate sponsorships just left us because they said that's too radical of opinion. And we're saying it's not a radical opinion to say we need to do something right first instead of putting something in and then trying to change it years and decades later. So we're struggling right now. You had an appeal for funding? Here's my appeal for funding. We're struggling right now. We need to get the word out that good things can happen, but we also have to make sure we do it right. But we're doing the right thing by coming out with these statements saying let's not jump into this whole blue light problem without first knowing what's going on. Okay, there's a lot of too much text on there. I apologize for that. We're concerned with luminaire design. Right now, the efficacy of an LED is such that every light photon emitted has to be utilized. We don't have the luxury of waste, as opposed to your basic high-intensity discharge lamp. You can shoot light in all directions. Everything's got to be focused down. Well, when the efficacies improve, and they improve radically. It's about 10% every 6 months. The efficacies move up. But light's going to start shining everywhere again, and we just don't want to see that happen. And the other thing that's important is the shorter wavelengths. There's a lot more blue light associated with the LEDs because the parent LED chip of a high brightness white LED is in fact blue. Other thing, beware of aftermarket lamps. There's a lot of garbage that's being thrown on the market right now, seen to be as suitable replacements for old technology, and they're just not there. A very important function with LEDs is you have to have excellent thermal management. The junction of an LED gets very, very hot, and if it gets too hot, it ruins its lifetime. And there's junk like this being thrown on saying, just screw it in to be just like replacement for an old lamp. Well, that doesn't work because you figure here's the screw base here. Yeah, that goes into a socket. It's usually ceramic, which is designed to insulate as opposed to conduct. So you're actually losing the most important thing, conduction, to get heat out of there. And this stuff is out there, and it's promoted as LED and new and wonderful, therefore you should put them in. And there's ignorances running terribly in the LED world. There we go. Bad design out there. You can go purchase these things today as new, wonderful LEDs, and they're not. These are actually using, well, the exception of this one up here, that's using a single chip, one chip. These are actually using the old 5mm white ones that you see in a cheap flashlight. Okay, this is garbage that's being thrown onto the market, being touted as LEDs, therefore you're doing the new wonderful thing by being green, and you're not. That's terrible stuff. There is good design out there, and you'll notice it's the most appropriate thing, flat, full cutoff. There's excellent design. This produces very little glare, which is kind of impressive. You can actually read the name of the product here. This is the old traditional look. The LEDs are up here shining down. So new manufacturers are coming up with good products. It's not to say that everything's bad. There is good stuff out there. But the wonderful thing about LEDs is the ability to control. You couldn't do it with the older technology. You can lower the light levels when you need it. You can have curfews. You can say, okay, at 10 or 11, we dim the lights down to X%. It doesn't have to be on or off. It can be 20%, 40, 50, whatever the municipality needs. And it can be slowly ramped up or instantly ramped up in the case of occupancy presence. You can dim it when the moon is light, which is very interesting. You figure, hey, you've got this natural source. Do we really need all this other illumination out there? You can actually dim it